In the previous lesson of the Amazon EKS series, we learned how to provision EKS cluster and the most important components of EKS that we must know to get started. In this series, we are going to learn to deploy a simple web application. Hi, I'm Robin Gautam. I'm AWS certified cloud and DevOps engineer, and I'll be your presenter today. So let's get started. So in the previous series, we had provisioned Amazon EKS cluster using EKS-CTL utility. We were able to see that it was creating a CloudFormation stack for us to spin up the resources. And we were finally able to see our EKS cluster in AWS Management Console. So the next step is to update the kubeconfig. So let's do that using this command. So I have my resources in USS2 region, so let me specify USS2. And it says added new context. So it added new context and updated my kubeconfig file. So if I hover over to the Kubernetes over here, we can see our context has been updated. So before we start deploying our application onto Kubernetes, I'm going to quickly walk through the contents of Kubernetes deployment and service file. So here I have an example of minimum configuration for deployment and service file. So let me start with the metadata section. We can see we have metadata section in both the deployment as well as the service file. In simple words, metadata is data about the data. In context of Kubernetes manifest files, in metadata section, we specify the name of the component itself. It can also contain the label with key and value. Now another important component is specification, which is specified by spec. In the specification section, we include the configuration we want to specify for that component. We use kind for declaring what you want to create based on which we have the different API version. So here in this example, you can see we have a kind of deployment and kind of service, and based on which we have different API version over here. Note the attributes we specify on the spec section varies on the kind. So deployment files attributes only apply for deployments and service file attributes only apply for service. Finally, status is another important part of configuration carried by Kubernetes, where Kubernetes always tries to maintain the desired state by comparison with actual state. For example, we have an application with single replica. If in case we include two replicas in the same file and deploy it again, Kubernetes will work on maintaining the desired state of replica for the pod that we have specified in the deployment file. And that information is updated in etcd, which, if we recall from the previous series, is the brain of the Kubernetes cluster, which stores the cluster data. Kubernetes manifest files uses the YAML syntax, which is human-friendly and easy to understand. However, it is strict about indentation. Now, if we look inside of specification, under the spec section, we have the template which has its own specification over here. Now, whatever configuration we have under the template section is the configuration for the pod. The spec under the template section is the blueprint for the pod, which specifies things like which image should it use, which port should it open, and what is going to be the name of the container, etc. Now, how does deployment and service get interconnected with each other even if we deploy them separately? So the metadata inside the template section contains a label which has a key value. In this case, we have app CloudYeti Flask, which must match the selector key value over here, which is the same as app CloudYeti Flask. Okay, now we mapped pods managed by deployment configuration file to the service configuration file. But pod should also be mapped to its own deployment file. Therefore, we should specify match levels for mapping pod to the deployment. Now let's move to another important piece that must be configured in service and pods, which is ports. Now service has the port where the service is itself accessible at. But the service needs to know to which pod to forward the request and to which port the pod is listening. So for that we specify the target port. So in our example, the target port of 5000 must match the container port of 5000. And node port is for exposing our service on the browser. And using only node port instead of load balancer is only appropriate for development purposes and not suitable for production workloads. Now on the deployment file, we have specified the replica as 1. So this specifies the number of pod that the deployment will be running. Now before we apply these configurations, I'm going to quickly go over this image section. So on the image section, we can either specify the image from the ECR, which is Elastic Container Registry in AWS, or we can specify an image from Docker Hub. This particular image is pushed in the Docker Hub. So our pod can pull this particular image from the Docker Hub itself. By default, AWS only provisions the classic load balancer if we use type as load balancer. But if we want to specify the network load balancer, then we need to add this key value under the annotation section to provision the network load balancer. So now that we went through all the configurations inside of the deployment and service file, let's deploy our application. Note that I'll be linking the repository link in the description below so that you can clone this repository and use this deployment and service file to provision the application in the EKS cluster. So first let me deploy a service without a load balancer, and then we'll deploy a service with the load balancer. So for that, on the service YAML file, let me comment this annotation section as well as the type of load balancer. Now let me apply the changes for deployment and service file. So you can see I have deployment and service created. So if we do kubectl get all, you can see our service is exposed in the node port type. And we have the default service for Kubernetes. So now let me use another command, kubectl get nodes -o wide. This command gives the external IP over here. Now if we do kubectl get pods -o wide, so you can see the node IP over here is associated with this external IP. So let me copy this external IP and let me paste on the browser with the port of 5000. And you are going to see our application is not up. So in order to access the node port, the 5000 is the application container port. So we must specify the node port. So if we see over here, our node port is 30301 that we have specified on our service file. And still I am not able to access this on the browser. If we specify the type as node port, we also need to open the security group for this port. So let's go ahead and do that. So let me go to the security groups. Let me click on any of these instances. If I go to the security groups, I can see there are two security groups created which are attached to the node. The first one is the remote access to SSH into the node. The second one is the security groups where we have rules to access to other components within the cluster. So if we attach an inbound rule over here with the same port of 30301 and let's open it to the internet, and we know this is the node port. And let me save the rules. And now you'll be able to access our application in the browser. You can see our application is accessible on the browser using the node port and the external IP. So now that we have covered the node port section, let's also create a load balancer. For that, let me again go to the service file. And over here, let me uncomment these annotations as well as the type. And let me just deploy the service again. Now you can see our service is created. Now if we use kubectl get-allo command again, you can see we have our external IP over here. Now if I copy this external IP and paste it onto the browser over here with the container port which is 5000, we should be able to get our application here. Since the provisioning of the load balancer takes few seconds, let's give it a moment. So you can see our application is accessible from the load balancer as well. So if you want to see the load balancer, we can go to load balancer section over here. So on the load balancer tab, we can click on the listeners and you can see our application is listening on the 5000 port. And it's forwarding a request to the nodes where our ports are located. So if I click over here, on the targets, you can see we have our nodes. So these are our two nodes. Right now the status is initializing. We should soon be seeing this healthy. So now let's test the self-healing architecture of Kubernetes. Now let's see what happens if I delete the pod. If I do kubectl get all, or if I just do kubectl get pods, so you can see after deleting a pod, immediately it started to create a container again. The reason is Kubernetes always tries to maintain the desired state. In the desired state, Kubernetes is looking for the replica of the pod that needs to be running on the node is 1. So Kubernetes always tries to maintain at least one pod running on our node. So if I again use kubectl get pods, you can see our application is running. And we can also verify by refreshing this page. And using the same service load balancer URL, our application is accessible. So to provide with the more fault-tolerant architecture, let me go over to our node and let me terminate our node. So let me go to EC2. So among the two instances, let's say one of the instances got terminated. So shutting down. So now we only have one node over here and our another node got crashed. Now even if our application was running on the pod under the different node, Kubernetes makes sure to schedule that pod to the new node. So if we use this browser to refresh our page again, so let's give it a couple of seconds and you can see our application will again be up in the same URL. And if I refresh, you can see even if we terminated our single node, it again brought up the desired node. Now the reason the new node came up is when we spin up the EKS cluster using EKS serial utility, it creates a auto-scaling group which is backed by the launch template. And as per our configuration, it brought up the new node back. Now if I refresh this, you can see our application is accessible with the same service load balancer. Now if you want to do further testing, you can go ahead and delete both nodes and wait a few minutes till it brings the two instances back up. And after that, if we access the same service using the same load balancer, our application should still be up. So let me quickly go over to one more thing. So if you go over to EKS, over here, if you click on the cluster, and if we click on the workloads, we can see what else pods are in ready status. So the application that we have deployed is in the default namespace. We can also specify the namespace within the deployment file itself. And you can see we have 1 out of 1 pod ready. So in our deployment file, we can also specify which namespace we want to deploy our application to. So furthermore, you can also manage access to multiple users using a config map. You can see we can provide a map user blocks where you can provide a user ARN and username for the different user who can interact using their local to trigger the APIs in Kubernetes. And to do that, we need to use this command. So let's not forget to delete our cluster. Let's use this command to delete our cluster. EKS cdl delete cluster and then our cluster name, which is EKS-cluster. So using this command, EKS-cdl utility also deletes the CloudFormation stack. So if you go to AWS Management Console and if we click on CloudFormation, you can see the status is delete in progress. So let's wait a few minutes till it gets completely deleted. Hope you enjoyed watching this video. Thank you.